Here we have a pre-calculus problem. Okay, let's go with the question. A shipment of 14 microwave oven contains 6 defective units. A vending company has ordered 4 of these units, and because each is identically packaged, the selection will be random. Okay, a vending company has ordered 4 out of these 14 units, and each unit has been packaged separately, and also the selection of 4 out of these 14 units is random. And we have to find probability in 3 different situations. The first situation is given in part A, that is we have to find probability that all 4 units are good. The second one is part B, that is exactly 2 units are good. We have to find probability for this one. And part C is we have to find probability that at least 2 units are good. Okay, let me consider the given 14 units. In these 14 units, let me consider capital D as the number of defective units, that is 6. And D prime, capital D prime represents the number of non-defective, that is good units, that is 8, because when I subtract the 6 from the total number of units 14, I am getting 8. So this D prime represents the number of good units, and this capital D represents the number of defective units. Okay, now whenever I want to find probability, first I must be getting the total number of all possible outcomes in the experiment done. So here the experiment is we select 4 out of these 14 units randomly. So in how many ways can we select 4 out of these 14? So that total number of ways is a sample space that has to be written in denominator. Here, for example, let me consider the 14 units as A, B, C, D, E, F, and it keeps going up to the 14 units. Okay, now we have to select 4 out of these 14 units. Okay, now let me say A, B, C, D is the first selection, and the second selection may be B, C, D, E, and the third selection may be A, C, D, E, and the fourth one may be B, D, E, F. So in this way, we have to count the number of ways of selecting 4 out of these 14 units. Can we count manually like this? No, it's not possible. Even if it is possible, it will take more time. So we have to find some other way to get to the total number of ways of selecting 4 out of the given 14 units. For that, we can use a counting principle combination. So that is 14 C4. So this combination will give the total number of ways of selecting 4 out of the given 14 units. So this is a sample space for all the 3 parts A, B, and C. So let me write the sample space 14C4. Okay, now I have written the sample space over here in denominator. Okay, now let's try to find probability for part A. That is, we have to get probability that all 4 units are good. If all 4 units are good, then the 4 units will be selected from this 8, because this capital D prime represents the good units, and this capital D represents the defective units, that is 6. So if all the 4 units are good, then all the 4 units will be taken from this 8. So in how many ways can we take 4 units from this 8? So for that one also we can use combination like what we have done over here. So then we get 8C4. Then if I select all the 4 units from these 8 units, then how many units will be selected from this 6 units? No units will be selected from the 6 units. It can be written as 6C0. Okay, so we select 4 from this 8 units, good units, and 0 units from this 6 units. We do both, so we multiply according to fundamental principle of counting. Okay, now we have to calculate this 8C4, 6C0, 14C4. Okay, first let's calculate the value of 14C4. Okay, for that we have to consider the combination. Usually the combination is the NCR, we write it as NCR, and there is a formula for evaluating the value of this combination. So this N represents the number of things given, this R represents the number of things selected from the given N things. So the formula is N factorial divided by N negative R factorial times R factorial. So this is a formula we have to find the value of this combination NCR. And also we have to consider an important property in combination, that is NCR equals to NC N negative R. That is, in the given combination, we replace this R by N negative R. That is, we subtract this R from N. Whatever value we are getting for that subtraction, that has been taken out here. So the result of this combination, will be same. And also here you have a question. Why do we have to take that N negative R at the place of R, and we change this one, we change the structure? So because if there is a chance to decrease the value of R, we can use a property. For example, let me consider 20C15. Okay, now in this combination, the value of N is 20, the value of R is 15. Now let me use this property over here in this combination. What will happen? That is 20C, we have to subtract the value of R from N, that is 15 has to be subtracted from 20, then I'm getting 20 negative 15, then we get 20C5. Okay, here when I use the property over here in this combination, so 20C15 becomes 20C5. So the result of this combination, will be equal according to this property. Okay, when I use the property over here, the value of R has been decreased from 15 to 5. So since the value of R has been decreased when I use a property over here, so the calculation process will become easier when the value of R becomes smaller. So we can calculate the values of both the combinations and we'll be getting the same result, but the calculation process of this one will be easier because the value of R is smaller instead of this one. Okay, now let's consider the combination 14C4 that we have in denominator over here. That's a sample space. Okay, so 14C4. Okay, can I use a property we have over here? Is there any chance to decrease the value of R? No, I don't think, because of 14C, 14 negative 4. 14 negative 4, that is n negative R, means it becomes 10. The value of R has been increased. When the value of R is increased by using this property, there is no use. So better we can calculate this combination as it is. Okay, so do we have to calculate the value of this combination using this formula? Always we don't have to use this formula if the value, if the R is given as a numerical value. Here let's consider the R. R is 4, it's a numerical value. Since it's a numerical value, without using this formula, we'll be able to evaluate the value of this 14C4 using a shortcut. What is a shortcut? For that, we have to consider the value of R. What is it? It's 4. So since the value of R is 4, this 14 has to be reduced for the next 4 consecutive integers and multiply them. That is 14 times, 13 times, 12 times, 11. Okay, I have reduced 14 for the next 4 consecutive integers. Here particularly I have considered 4 consecutive because our value of R is 4. And here we may have a question. What if I have 14C5? Do I have to reduce 14 for the next 5 consecutive integers? Yes, exactly, because the value of R is 5. Okay, once you are done with this one, it has to be divided by the factorial of the number. The factor of the value of R over here. That is 4 factorial. 4 factor can be written as 4 times, 3 times, 2 times, 1. That is 4 has to be reduced for the consecutive integers up to 1. 4 factor means. Now we have to simplify this one. 4 times 3 is 12. This 12 and 12 will cancel out. 2 goes into 2 1 times and 2 goes into 14 7 times. And when I multiply this 7, 13 and 11, I am getting 1001. And it has to be divided by the denominator. The denominator is 1 times 1. So even when I divide this 1001 by 1, still I am getting 1001. So the value of this 14C4 is 1001. Okay, now we got the value of 14C4. And also we have to calculate the value of 8C4 in the same way. Let me do it. That is 8C4 equals to. So here, even if I use the property over here, the value of R will remain same. That is 8C, 8 negative 4 is still 4. So now there is no use of using this property. Now let's evaluate the value of this combination, the shortcut what we have discussed over here. 8 has to be reduced for the next 4 consecutive integers because we have 4 over here, the value of R. Then I'm getting 8 times, 7 times, 6 times, 5 divided by 4 times, 3 times, 2 times, 1, because we have to write 4 factor of the R value over here. So 3 times 2 6, this 6 and 6 can be cancelled, and so 4 goes into 4 1 times and 4 goes into 8 2 times. When I multiply this 2 and 5, 10, 10 times 7 is 70. So when I multiply the numbers in numerator, I'm getting 70. In denominator, we have 1 times 1 is just 1. 70 divided by 1 is still 70. Okay, now I got the value of 8C4. Okay, now let's get the value of 6C0. Okay, in this combination, the value of R is 0. In a combination, if the value of R is 0, then the value of such combination is 1. It doesn't matter what's the value of n. Whatever value I have for n, it doesn't matter. If the value of R is 0, the value of this combination is just 1. Even if I take 1000C0, its value is also 1 because the value of R is 0. Okay, now we have the values for all these three combinations, 8C4, 6C0, or 14C4. Now let's plug in the values over here. Then I'm getting the value of 8C4 is 70 times the value of 6C0 is 1, and the value of 14C4 is 1001. So 70 times 1 is 70 divided by 1001. Okay, now we have to check whether we can this fraction can be simplified. Okay, I know that 70 is divisible by 7 and also 10. Even though 70 is divisible by 10, but 1001 is not divisible by 10. Because to simplify this one, we have to get the common divisor for both 70 and 1001. That is for both numerator and denominator. So 10 is the divisor for this one, but 10 is not the divisor for denominator. But I know 7 is the divisor for 70. Let's check whether 7 is the divisor for 1001. Yeah, 1001 is evenly divisible by 7. So we can divide both numerator and denominator by 7. When I divide this 70 by 7, I am getting 10. When I divide this 1001 by 7, I am getting 143. Okay, now I have simplified the fraction we have here. So that's all the simplification we can do. So 10 over 143 is the probability for selecting all the 4 units are good. That is, this is the answer for part A. Okay, now let me erase the stuff and answer part B. In part B, we have to find probability for exactly 2 units are good. Okay, for this one also we have the same sample space, because for in all the 3 situations we select a 4 out of 14. So the sample space is 14C4. Okay, so when we find probability for exactly 2 units are good, so those 2 units will be taken from these 8 units, because these 8 units are good, and the remaining 2 units will be taken from the 6 defective units. That is, selecting 2 units from 8 units, the number of phases given by the combination 8C2, and selecting 2 from this 6, the number of phases is given by the combination 6C2. Here we do both, that is, we select 2 from this 8, 2 from this 6. So both the things are happening. When both the things are happening, we have the word and between them. So whenever we have the word and between the 2 events, we have to use multiplication. That is, according to fundamental principles of counting, when we have the word and, we have to use multiplication. There are 2 fundamental principles of counting. One is and other one is or. For or, we have to use addition. Since we have and over here, we have to use multiplication. Okay, now we have to evaluate the values of these 3 combinations. Already we know the value of this combination 14C4, that is 1001. Okay, now let's calculate the value of 8C2 using the shortcut what we have already discussed. That is, 8 has to be reduced for the next 2 consecutive integers. That is 8 times 7. It has to be divided by the factorial of this number. That is the value for 2 factor, that is 2 times 1. 2 goes into 2 1 times, 2 goes into 8. 4 times 7 is 28. So, okay, so 28. Times, okay, here 62. 62 means 6 has to be reduced for the next 2 consecutive integers. That is 6 times 5 divided by 2 factor, that is 2 times 1. So 2 goes into 2 1 times and 2 goes into 6 3 times. 3 times 5 is 15. Okay, 28 times 15. Already we know that 1001 is evenly divisible by 7. We have done in part A. So there is 7 goes into 1001, 143 times, and 7 goes into 28 7 times. So since I find that the 2 numbers 28 and 1001 which have the greatest, which have the common divisor 7, I just decided to simplify this one by 7 times table. Okay, now we can multiply this 7 and 15. 7 and 15 is 105, and here in denominator we have 143. Okay, so that's all the simplification we can do. So this is a probability of selecting exactly 2 units are good. That is 105 divided by 143 is the answer for part B. Okay, now let me erase the stuff and answer part C. In part C, we have to find probability for at least 2 units are good. Anyways, sample space is same, that is 14 C4, and also we have the value for this 14C4. Okay, now let me consider the event for which we have to find the probability, that is at least 2 units are good. So out of selected 4 units, at least 2, that means minimum 2 units are good. If minimum 2 units are good, then the minimum 2 or 3 can be good, or all the 4 can be good. So we have to consider all these 3 possible cases. That is, at least means minimum 2 to be good. If minimum 2 means maximum can be greater than 2. That is, 3 can be good or 4 can be good. Okay, let's consider the first case. That is, 2 units are good. 2 units are good means that those 2 will be selected from this 8, and the remaining 2 will be selected from the 6 defective units. Then the combination will be 8C2 times 6C2. So this is a combination we are getting when 2 units are selected. Since minimum is 2, we can go more than 2. If 3 units are good, then we will select 3 from this 8, 1 from this 6 to get the total 4. Okay, so R 8C3 and 6C1. Or we may select all the 4 are good. In that case, we will select all the 4 units from this 8 and 0 units from this 6. Then we get 8C4 times 60. Okay, here when I consider these three cases, all the three cases are not simultaneously possible. So either we can select 2 good units, or we can select more than 2, that is 3 good units, or we may select all the 4 units are good. That's why I have taken the word or. Okay, or means according to fundamental countings of principle, so we have to use addition. Let me write over here 8C2, 6C2 positive, then we write 8C3 times 6C1 positive. I just replace the word R by positive sign, then I'm getting 8C4 times 6C0 divided by 14C4. Okay, now let me erase the stuff we have over here and continue the problem. Okay, now let's do the calculation. So 8C2, the value of 8C2 is 8 times 7 divided by 2 times 1. So that is 8 times 7 is 56. 56 divided by 2 is 28. The value of 8C2 is 28 times the value of 6C2, that is 6 times 5, 30. 30 divided by 2 is 15. And now let's calculate the value of 8C3, that is 8 times 7 times 6 divided by 3 times 2 times 1. 6 will cancel. 56 is the value of 8C3. Let me write over here 56 times the value of 61. In a combination, for example, if the value of R is 1, then the combination equals to whatever value we have over here, that is n. So for 61, the value of R is 1. So what is the result of this one? So we just have to consider the number at the place of n, that is 6. So 61 is equal to 6. Let me write over here positive. 8C4 already we got the value of 8C4, that is 70. And since the value of R is 0 in this combination, its value is just 1 divided by, already we know that the value of this 4C4 is 1001. Okay, now let's calculate. Let me multiply 28 and 15. When I multiply 28 and 15 over here, I am getting 420 positive. Let's multiply 56 by 6. When I multiply 56 by 6, I am getting 336 positive. 70 divided by 1001. Okay, now let me add 420 plus 336 plus 70. I am getting 826. Let me write it over here. Divided by 1001. Okay, here added 3 values, this one, this one, this one. But each value is a multiple of 7. So because here in this product, we have 28, 28 is a multiple of 7. And in the second product, 56 times 6, 56 is a multiple of 7. And in this product also 70 is a multiple of 7. Since we add 3 multiples of 7, so the result 826 also must be a multiple of 7. So already we know that 1001 is a multiple of 7. So since both of them are multiples of 7, we can divide both the numbers by 7. Let me do it. So when I do so, when I divide 826 by 7, I am getting 118. Okay, here when I divide 1001 by 7, I am getting 143. Okay, now I got the probability for at least 2 units are good. That is part C. The probability is 118 divided by 143. Let me write the answer over here. So this is the probability for part C.